All right. Didn't expect that to start the video, did you? So we're only missing like 20% of the class. Very proud of the 80% that showed up today. Well, some of you are eating in my class, which always makes me happy. See the definition of sarcasm. So last week we started talking about stoichiometry. In order to discuss stoichiometry, though, you have to understand molar mass, right? You need a periodic table. You need a calculator, unless you are one. True? Most of us are not calculators. Some of us can't even handle third grade multiplication anymore. I swear I said like 6 times 2 to a kid yesterday, and they were like, "Can I just have the calculator?" I was like, "Oh." All right. So, what page is worksheet 1 on? 161, 59, 61, 161. And you might hear, if you're watching the video at home, some mumbling. That's the class talking. It doesn't barely pick you guys up at all, unless you like scream something. That's not a request. It's not a request, although I see some people contemplating right now. We basically only learned one new thing in stoichiometry. We just attached it to some old things we had already learned. So one of the first things we had to review, though, was how the heck do I find out what a mole weighs? So I made this little short how-to page that's not in your notes, but it's a good review. So how do I find out what 1 mole of a compound or an element weighs? What's the answer to that? How do you find out what 1 mole weighs? You look at the periodic table and find the molar mass. The periodic table is a list of masses that weigh 1 mole. Awkward people taking pictures, I hope, of the screen and not me. If you're taking pictures of me, we need to get a better Twitter feed for you. So here there were 2 aluminums. So I went to the periodic table, I found aluminum, and then I multiplied it by 2. Given that I'm not a calculator, I used 1. This does have parentheses. What does that 3 do on the outside if there's parentheses? Yeah, it gets multiplied by everything inside, so there's not 1 sulfur inside, there's actually 3 sulfurs. And there's not 4 oxygen, there's 4 times 3, which you all know is, oh, so proud of you, 12. So we have 12 oxygens, oxygen is 16 on the periodic table, 3 sulfurs, sulfur's 32 on the periodic table, 2 aluminums. We add all that up, and we find out that 1 mole for this compound is 342 grams. If it was a different compound, it would be a different mass. And you have to add together the pieces for every compound very carefully. And also in years past, chapters past, unless you're repeating the course, we talked about how do you change moles into grams if you have multiple moles. So here we have, like, say, 3.2 moles. 3.2 moles is definitely more than 1. That brief interruption brought to you by Mrs. Hoffman. Okay. So we have the moles that are just randomly given in this question that I just made up, and we're supposed to find out what it would weigh. We just figured out that 1 mole is 342 grams. 3 moles would be 3 times heavier than that. Like if 1 person weighs 100 pounds, 3 people would weigh 300 pounds. It's the same conceptual thing, but with compounds. So we know what 1 of these weighs. What would 3.2 of them weigh? Well, evidently 1,094. Again, that's something we learned like 2-3 chapters ago, right? I think at the beginning of this quarter. And a bunch of people may want to go back and review that because this quarter is ending very rapidly. What do we have, like 7 days to the quarter ends? For like 4 school days? All right, so keep that in mind if you're contemplating retakes of any sort. You're rapidly running out of time. Did you just cross yourself? That's funny. Or very, never mind, I guess I ran into a hole there. We also learned how to balance equations. Why do we balance equations? Because atoms can't magically disappear. If you start with 2, you have to finish with the same 2. They might have different friends afterwards, right? They might rearrange who their partners. Like here, lithium is by itself. Afterwards, some lithium has gotten together with sulfate. It's got some friends now. Unfortunately, in this scenario, aluminum had some friends, and now it doesn't. It's by itself. That's kind of sad. Why do we balance them? So that all of the pieces are still present, and it tells us how things move around in a ratio form. We can take a reaction like this and write ratios. We could say 6 lithiums will produce 2 aluminums, right? In this reaction, 6 lithiums produce 2 aluminums. What are some of the other things we could pull out of that? If I said 3 lithium sulfates, how many aluminum sulfates would that be? What's the ratio between lithium sulfate and aluminum sulfate? Yeah, there's nothing written here, but it's an implied 1, so it's a 3-to-1 ratio. Now what I've left out of there is the unit. The unit is moles. Reactions are always actually in terms of moles. We just don't write moles in every single time because, man, wouldn't that be a pain. If you had to write in 6 moles react with 1 mole to produce 3 moles and 2 moles. But that's really what a reaction is. It's based off of the moles present and how the atoms are moving around. So that was the big new deal we learned in this chapter, is that we could write 6 moles of lithium for every 2 moles of aluminum. We could pull ratios right off a reaction. You put that together with finding moles from the periodic table, and we've got stoichiometry. So, is this question 1? Great. And I had some stuff filled in for you, and you just had to kind of like fill in the missing pieces. I'm going to reiterate, while all of my answers are rounded to the proper sig figs, your answers don't need to be if you're only hunting for an A. If your goal is to get an A+, then they have to be. All right? So I'm going to let you make that mental decision. I will review the sig figs every single time. Be like, hey, there's 2 sig figs, blah, 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 blah. But if you're still getting 17 and the answer's 112, you shouldn't be worrying about sig figs. You should be worrying about, how do I get 17 point something, something, something? How do I get close to the answer? So the very first question, I had the given written down for you, but if this hadn't been written here, how would you know to write down 5.9 moles S? Then the question. You have to read the question, and then you write down the value you were given, which is why it's called the given. You have to write down the number, the unit, grams, moles, artichokes, that's not a unit, meters, whatever the unit is, and the compound or element that applies to that. You have to write down all 3 things. So you got to write down all 3 pieces so that you know what to do in the next step. I had the next step partially set up for you. Moles of sulfur, moles of aluminum sulfide. How would you know to change to aluminum sulfide? Again, it's in the question. What element does it not ask about at all in the question? Aluminum. So you don't have to worry about the aluminum at all. This is a question between the sulfur and the aluminum sulfide. You had to fill in the ratio. What's the ratio hiding behind the black box? Is it 2/3, 1/3, 3/1? Say again? 1/3. If the aluminum sulfide's on top, there's 1 aluminum sulfide. Sulfur's on bottom, there's 3 sulfurs. This is the big new thing in this chapter, looking at a reaction and getting a mole ratio. Now what do? It's all set up. I do the math, right? 5.9 times 1 divided by 3. Calculator spits out an answer that probably doesn't number in. Is that like a repeating 6 that goes for bajillion years? Yeah. So I'm going to round it based off of sig figs. The ratio is exact values, so they're infinite. The given was how many sig figs? 2. So I wrote down 2. I rounded it to just the first 2 values. The 6 rounds up. 9's turn into 0, right? So there we go. Again, what is your worry at this point? Am I getting about 2? The other commonly wrong answer is like 18 point something or 17.9, and that's if you write the ratio wrong. All right, second question. We got to put the ratio in here. You had this stuff filled in, so you have to put the right ratio in here. These numbers, again, when it's moles to moles, come from the reaction. They were 2 for every 1. This one, though, had, what is the mass of silver nitrate? The grams. So we just reviewed, how do you find the relationship between moles and grams? You go to the periodic table, and you add up the pieces. So that's what this is. This is silver, Ag, nitrogen, and O3. Bam. 169.88. Hey, Mr. Murphy. Yes, person who didn't ask a question. I did 2 AgNO3 because that was a 2. Was that wrong? It's not wrong, but if you're going to do 2, you'd have to put a 2 here, and you'd have to do what to this number? You'd have to double it. You could do that, but you've already got the 2 taken care of, don't you? You probably don't want to use that 2 twice. If you do, you're going to cause yourself probably more of a problem. So first we have the mole ratio between the 2 compounds, and then we have the molar mass ratio, the mass that represents 1 mole. All set up, 1291, and then sig figged to 2 sig figs because of the given. So about 1291. If you're in the 1291 ballpark, you're good. Preguntas estudiantes aquí. Yes. Where did I get the 107? So the mole to mass thing, everything, all the values come off the periodic table. So silver on the periodic table, 107.87. Nitrogen on the periodic table, 3 oxygen. So then I added these pieces up so I would know one of these as a group weighs, right? All right, number 3, the search for more questions. All right, this one, the given was in grams. Ew. Grams are not a chemist's best friend. The only people who like moles are chemists, but we love them. So we typically change to moles like that. I don't know if the snap, let's make sure the snap got in the video. So if this is grams, the bottom unit needs to be grams so that they cancel. True? Where do I get the values for grams? The answer is either the periodic table or the balanced equation. Pretty much every question you ask me, there's one of 2 answers. It's either I got the values off the periodic table or I got them from the balanced equation. I guess there's one other. It's like I wrote down the given. So you start off by writing down the given. This given's in grams. I got to go to the periodic table then. So this is the mass of water off the periodic table. 2 hydrogens and an oxygen is 18. That represents 1 mole. Every periodic table is written in terms of 1 mole. The units, that was a deep sigh right there into the microphone. Sorry about that. Grams cancel grams. What would the unit be left if I stopped right now? Moles of water, right? So that's why we're setting it up, is that these units and those units cancel. Now I have moles of water. So I have water. And this question asks about butane, and then it's nice enough to give the formula because you probably haven't taken organic chemistry yet, except for Jason back there. The rest of you guys haven't taken organic chemistry, so you don't know butane's formula. He doesn't really know butane's formula. So that is butane. What is the ratio between water and butane? 2 to 10? Or is it 10 to 2? Does it matter if you write 10 over 2 or 2 over 10? Oh yeah, it matters a lot, right? If you multiply by 10 and divide by 2, that's drastically different than if you multiply by 2 and divide by 10. We could do a monetary exchange to make the point. We won't. So you have to make sure you write the correct thing on top. And this is where littler Murphy, the high school version of me, struggled. Because I would regularly write 2 over 10 or 10 over 2. I would kind of 50-50 it, which was my score. because I didn't take these units very seriously, if that's moles of water, then the 10 goes on the bottom. Because these units and those units better darn cancel. Bam, bam, they match. And because they're on top and bottom, they cancel. And then the unit that didn't get canceled was the one we were looking for. And sig figs, again, kind of annoying for some people. 0.077 something, 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 something. I don't know the exact super long calculator answer. But we have some lefty zeros. These guys are to the left of the 7, so they don't really get counted. So the first real value was a 7, followed by another 7. What? This was 2, 6.9. It's almost always the given. The givens are usually the limiting factor. The periodic table's pretty darn exact values. They're not exact values, but they're pretty good. The ratio is actually exact values. You have to have 2 of these for every 10 of those. So we have infinite here and here. That's an exact ratio. And the periodic table is based off a perfect 1, which I don't think you could ever get a perfect 1 mole on there. But, so this is an estimate. This is our estimate of what 1 mole weighs. So I would say that's 4 sig figs. So of 2 in the given, 4 infinity, 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 I went for the first 2. All right. Are there any training wheels left? Have all the training wheels been taken off? Okay. So this is the first one where you kind of have to like really start to wade through the mud yourself. And the key to that is looking at the units. This was grams. What's hiding behind the bottom then? Grams, right. And that grams always comes, that value from then on, after you write down the given, either comes from the periodic table or it comes from the reaction ratio. So if this is grams, I'm going to use the periodic table to convert it to moles. It looks like we have 1/4 of a mole of oxygen because 8 divided by 32 is about 1/4. Right? You don't need to stop and do the math though. You can just let the calculator pick up all the math. Your job is to correctly set it up. All right. So now we've changed it to moles of oxygen. And then the next question, what goes on the bottom? Again, to cancel it out, it should be moles of oxygen. Once you get to that, hey, my moles are now on the bottom step, this is where you can convert to something else. What are we trying to convert to in this question? Yeah. We're trying to convert to iron oxide. Is that Fe or is that Fe2O3? Yeah, not this one. Right. So we're trying to find that. So this is probably 2 moles of iron oxide. All right. So we divide by 32, multiply 2, divide by 3. There are a bunch of different ways to do this in your calculator. And if you haven't, like if you don't have it like in your calculator or haven't tried it, you need to, because I had 5 different people making the same mistake. It's really frustrating when you have everything set up correctly and then get the wrong answer, isn't it? I think we've all done that in math. I know I have hundreds and hundreds of times. In fact, I've done it in chemistry where I have everything set up and I just type something wrong because I'm slightly dyslexic. But here, the most common issue is people don't divide by all of the things on the bottom. They accidentally multiply by 1. Okay. More training wheels. Completely gone. This is grams. I'm going to change it to moles. Can I zoom in a little more? Let me try something here. Bam. That's better. So we were given grams. Got to write down all the pieces. 7.35 grams of oxygen. I had a couple people write O, but if you're not sure what the formula for oxygen is, where can you kind of get some help in this question to figure out the formula for oxygen? You go to the periodic table. Right here on the question it says O2. Did anyone write just O? Because if you write just O, you might think, say, 16. But you got to remember that oxygen's one of those ones that have to be doubled up. They call it the diatomics, Hofbrinkels or something like that. Right? So I've changed it to oxygen. What should I do in the next step? What goes at the bottom? Oxygen, water, sodium hydroxide, sodium oxide. What goes at the bottom? Oxygen. This unit always travels to the bottom to cancel out. Travels, that's weird. And this one is because there's only one oxygen in the reaction. And at this point, it's finally that weird, like, what do I do next? Again, you read the question, you figure out what you're looking for. We are looking for water. It says there are 2 waters. And for every oxygen, there's 2 waters. There we go. Alrighty, I'm going to scroll a little further down. If you need, you can pause it on your own. Well, when you guys can't pause it, you're live. Most of you. A couple of you don't look so alive anymore. Some of you kind of look asleep. Alright. Number 6. A nomenclature issue arrives, but we start off again with moles of oxygen. I write down the given. Whoa, this one is different. Pause your show there, Mr. Murphy. The last one was grams, wasn't it? So the first thing we did was change it to moles. This one is already in moles. And a lot of people have this run to the periodic table like mentality, which I love because I teach chemistry. But if we're in moles, we can already do the mole switch. We can already do the mole ratio. Can't we? It's like the first step has been done for us. They already changed it to moles, and they said, okay, keep going. So if this is in moles, this step better be the mole-to-mole ratio. So what would it be the mole ratio between? It would be between oxygen and potassium chlorate, which is this, right? So it would be a 2 and a 3. And again, pay attention to the compounds and the units. That's really how chemistry flows, how you kind of work a problem. So that's moles of oxygen, that needs to be moles of oxygen. I could change that to moles of anything else in the problem. It asks for grams, so I did have to then grab some values off the periodic table. That's potassium, chlorine, and 3 oxygens. Potassium, chlorine, and 3 oxygens, ClO3. All right. What's an approximate good answer here? Anyone want to tell us what they did? We have 5 times 2 is 10. Ooh, I can't do that math in my head. 40. So like 400 and something? Two sig figs. If you have 4 night, what's the unrounded answer? I saw you typing it. What's the unrounded answer? 416.67. Earlier I said if you're worried about an A+, you're worried about sig figs. If you're worried about just an A, you're not. That's because I will only assess sig figs for 1 point on each page. So if you get every question sig fig wrong, you're losing how many points? 1 per page. There's only going to be like 3 pages on the test. All right? Okay, maybe a 4th page because I'll just spread the questions out because people have big handwriting. But I don't want you to have like limited space on some of these questions. Like the homework is too cramped in my opinion. But I'm not going to ask more questions than 1 homework because that probably takes you 35 to 45 minutes after you know what you're doing. And most of you didn't know what you were doing last night. You were like just kind of swimming, treading water, hoping to keep your head above. Or in some people's case, you didn't like get in the pool. But you got to dip your toes in if you want to learn to swim. All right. How many moles of solid aluminum iodide? Just a second. Let me check something. And that's the secret to life and everything as we know it. Okay, so as I was saying a second ago, number 7, wouldn't want to skip that one. It'd be a huge faux pas. This one was mass, was asking for mass. So one clue I gave in one of my other classes, which might be yours, I don't know. You write down the given and you write down your goal. Write the given on the far left, 6.45 grams NaOH. Write down your goal on the far right, grams Na2O2. I don't know what the number is, but I know what the units are. I know the units and what I'm looking for. At this point, I don't have to read the words anymore, which that's what people typically hate. Well, students go in 2 categories: math friendly or not math friendly. And word problems, pretty much everyone hates. True? All right, except for that guy in the corner who's like, they were the best. So you write down the given. You don't have to read that part of the question ever again. You write down your goal, grams of Na. How do I know sodium peroxide is this? What is the name of this compound, which is not sodium peroxide? What is the name of this thing, which is not sodium peroxide? This is sodium hydroxide. Yes, I have harped on it 700 times. You need to know your polyatomic ions until at least June something or rather, right? They are not going away. I think that is like number 701 times I've said that. So that only leaves this one as the one you might not be able to identify. So that's your goal. You write down your given, you write down your goal, leave lots of space in between. I still have 1 or 2 people who are starting the problem in the middle of the page. You don't leave enough self. There goes me. All right? Right? You don't leave yourself enough space to work the problem, or gibberish, one or the other, whichever you choose. This is grams. Change grams to moles. Moles to moles, and then moles to grams, and then we have an answer. And I'm going to pause while you write. I think that was probably the funniest joke I ever told right there. Okay. So... No. So people don't realize that about dogs, but it's true. So again, we had the mass, we changed to moles, did the mole ratio, back to grams. This question is almost as hard as it gets. All of the concepts except for one are represented in that question. And the only other concept that's not represented there was going to get to it in the very last question. All right, number 8. Is number 8 on the back? Yes it is. And I need to do some slight editing to this. Let me pause for a second. Okay, so this question is slightly different. I want you to go ahead and imagine this as like question A and then question B, which is how it's set up in your packet. But the idea of this question is a little bit different than the others. Aluminum is reacting with iodine to produce aluminum iodide. You need 2 of these for every 3 of those, and then you only make 2 of those. What if I gave you 4 and 3? If I gave you 4 and 3, would you be able to make 2 or 4? Well, if you only have 3, you can only make 2. So if I have too much of one thing, I'm still running out of something. A lot of times with these questions, though, you can't tell what you're going to run out of. You can't look at the givens and go, I'm going to run out of iodine, or I'm going to run out of aluminum. Just ignore that for right now. So we have worked the first problem here. 0.5 moles of aluminum. It's in moles, so I go ahead and do the mole to mole ratio. And then I'm looking for grams, so I changed the moles of aluminum iodide to grams. Where did I get 407.71 from? Yeah, periodic table. So that's aluminum plus 3 iodines. I need to do the same thing. Oh, and I got an answer. I need to do the same thing, but with the other given, which I'm going to pause and write all that stuff down. Just kidding. I am going to record the work. So 0.720 moles of iodine. I2. Liney thing. Or dimensional analysis setup. This is moles of iodine. This better darn be moles of iodine. This needs to be moles of... What the heck am I looking for in this question? Aluminum iodide. Yes. If you heard the mumbles at home, they accurately said aluminum iodide. We could change between moles if we use the reaction. So, boom, de boom. So, 3/2. No, that was wrong. What did I just do wrong? Classic, fun for the whole classroom. Write it down upside down. Good job, Russ. That's me. 2 aluminum iodides, 3 iodines. 2 aluminum iodides, 3 iodines. The units help you put it in the right place if you pay attention, unlike me a second ago. All right. Now, this question, though, clearly says grams. And right now, I've just changed it to moles. So I got to tack on a moles to grams step. But the only thing nice about these two-part questions where they're given, when you're given 2 givens, is the last step is identical. Because you're still trying to find aluminum iodide. What is the molar mass of aluminum iodide? 407.7. You already have it, don't you? You've already done this work. You just get to use it again. Boom. And then you pick up a calculator, which if you don't have a calculator, one will be supplied to you. It may or may not have batteries in it. Right? 0.720 times 2 divided by 3 times 407.71 divided by 1. 196. That's a horrible looking 6. Try again. Oh, that's nice. So now we have 2 answers. 204, 196. Which answer is reality and which answer was a waste of time? 196. Once you hit 196 grams, that 196 is being actually made from iodine and from aluminum. The aluminum could have made a smidge more, couldn't it? But if you run out of iodine, if you run out of an ingredient in baking, you have to stop, or that's not going to taste right. Like we've run out of flour. Keep making cookies. This is not going to work. The other ingredients can't make up for the missing flour. Right? Have you ever tried to make something when missing a vital ingredient? It doesn't work, does it? What? Well, there are some things you could substitute, but you can't substitute much for flour. In this case, you have aluminum and iodine. Once you hit 196, you have used all of the iodine up. And you can't make more. So there's leftover aluminum. And let's label these other pieces over here. This now has a name. It is called the limiting reactant. Why is that a good name for that thing? Why is the iodine the limiting reactant? It limits our use. It limits our abilities. It limits how far we can go. This one, the aluminum, is called the excess. Because there's extra. There's going to be leftover aluminum. It's pretty rare to have the two work out to the exact same number. I've never been able to actually make that happen in the real world. But on paper, you maybe could. Let's try the next one. Nope. Skip. Come on. Number 9. All right. So, similar question. Let me zoom out just barely. That's way too much. Let me pause while I adjust the... That was a funny joke, Simba. Thank you for telling us that one. We really appreciate it. Yeah. She's still crying. She's laughing so hard. That was pretty good. That's pretty good. Whew. This one, again, in your future the givens will actually be given separately. So it'll say, Kellen has 10.45 grams of aluminum. How much copper can he form? 10.45 grams of aluminum. He gets an answer. Kellen has 66.55 grams of copper sulfate. How much copper can he form? Kellen, of those two answers, which one do you like better? No, that's not the right question. The question would be, which one of those is the theoretical yield? Which one should he be able to make? If he has these two things as givens, which of those answers should he theoretically be able to make? The answer will always be the smaller of the two. And I want to just hypothetically throw something out there. You're going to make a mistake. Do you agree that you might make a mistake? I don't know a single person in this room who hasn't made a mistake. I think I've made 4 this morning. So let's just hypothesize a mistake. Maybe you're wearing a red sweatshirt and you get this number wrong. If you get this number wrong, are you going to get... Sorry, I pointed at this number. You at home don't know what I'm pointing at when I use my fingers. If you get this number wrong, can you get that answer right? No. But what I want you to do, though, is look at your two answers and say the smaller one's the theoretical yield, because that's when the reaction would stop. So if you said this number was 59, maybe you just didn't see the 1 or something, that's going to make this answer way too big. It's going to be way off. And then you would have to choose the 36 as the answer to the follow-up question. It would also change those other two questions. What's the limiting reactant? What's the excess reactant? Because your answer to those questions is based off of the work. It's very similar to some a way of grading that we use in AP chemistry, where one question impacts the next question, which impacts the next question, which impacts the next question. I gave a question the other day on a test that had 7 parts to it. I don't have enough fingers. I'm holding up 7 now. And the very first part you used the answer again and again and again and again and again and again. But if you mess up the first part, that doesn't mean you lose all of the other points. You still have to use the answer correctly. So if you have 59 here instead of 159, that's going to mess this up, which would mess these up. But I'm expecting you to use the correct logic. If your answer here is, here's the fake answer, 72. Between 72 and 36, which one is the theoretical yield? The 36, because it's smaller, right? And then you get down here and you have to adjust these answers based off of that mistake. You don't know hopefully you don't know you've made a mistake. If you know you've made a mistake, then you should probably just go back and fix it. But if you don't know you've made a mistake, you proceed as if there isn't a mistake and you work the problem correctly. I actually think this question, what's the theoretical yield, is the easiest answer. Because theoretically speaking, somebody, let's call him Justin, could skip all of this work and write down 2 completely bad answers. 1 gram, 2 grams. Which answer is right, 1 or 2? 1. He's only going to get the point for the theoretical yield, the smaller answer. He already missed the 12 points that were back here. All right? That's not a very good strategy. And then he could say, because 1 is the smaller answer, such and such is the theoretical limiting reactant, such and such is the excess reactant. That's a horrible, horrible approach to the problem. But it's better than, I chose to leave the question blank because I didn't know what I was doing. Do you need more time? All right. Number 10. Number 10, again, we are going to adjust to get everything on the screen. There we go. Is this actually what number 10 says? Yeah? Okay. All right, I'm going to pause it while people write because you don't really want dead air. Oh, good times, good times. So, no. There's evidence in that story I can't reveal. Pending court cases. So we have We have two givens. Again, this would be like question A, question B. And you get two answers. And then question C is, which answer is the right answer? Also known as the theoretical yield. By theoretical yield, we mean all of this stuff we're doing is theory. In reality, if I hand you 9 grams of aluminum and 8 grams of sulfur, in the real world you exist in, not the digital one you stare at, do you think you would actually get 12.5 grams? You. If you convinced it? 12, you gotta believe, I like that. How about I'll throw in this caveat. With the equipment Potomac Falls has, maybe 11. Should you get 14? That was if you try hard enough. This should be the max. Based off of the math, this is the max value you should possibly be able to meet. Because you hit 12.5, what did you just run out of? Sulfur, right? It's all gone once you hit 12.5. Do you have leftover aluminum? Sure do. You could figure it out. It's not too bad. You have 6.5 grams of leftover aluminum. How did I figure that out? That's a good question. I like that you keep asking those questions. What is 9 plus 8? 17. Your second grade self is embarrassed. And you know it too. Like in second grade, you're like, come on, man. We worked so hard on 9 plus 8. Mrs. Hoey Johnson Franklin was so proud of us. Now we need a calculator for that. So 9 plus 8 is 17. You started with 17. How much can you make? 12 and a half. There's a missing 6.5 grams, aren't there? You can't go from 17 to 12 and a half. There's got to be some other mass. And that's the aluminum that didn't react. That 6.5 grams would be just aluminum going, hey, did I do it right? 4.5. Sorry, Mrs. Lynn is very embarrassed on my behalf. She was a great second grade teacher. I just embarrassed her. Sorry. Right, we started with 17. You're right. 4.5 would add up to 17. Nice work. I'm glad one of us can do addition and subtraction. Dang it. That was, not me. I hear you. But the aluminum is in excess. There'd probably be about 4.5 grams of aluminum just sitting there going, what, we're done? Right? How many grams of sulfur would be left over? None. There'd be 0 grams of sulfur left because you used it up. Right? You got me to giggle. That was impressive. He said, if you can't make matter from nothing, then you're slacking. I've lost my godlike abilities, so I guess I'm slacking. So here's what really happens. You do the lab, and you actually get a value, which in the question says you actually get this much, right? Like it says the word actual in there. Versus the theoretical. Actual versus theoretical gives you a percentage. And in our classroom, getting an 84% yield would be awesome. All right? There is a lab where we might get about 95% yield, but that's just because the reaction is so simple. The other issue there, though, is what if you're doing the reaction and you don't get the 4.5 grams of aluminum out? What if it's covered and it's stuck in there? You might not know what the total mass was. And that's probably the more... Well, you missed the entire story about everything. Like, they were actually good stories, weren't there? Yeah, you missed a good story. And now we're just rubbing it in the nose of everyone I didn't tell it to in the audience that's listening, which is also fun. All right. So the other thing about this question is it is everything. Not like, your heart, soul, and love. It is everything in this chapter. It's got every concept built into one question. Changing mass to moles, mole ratio back, doing it again, picking the smaller answer, limiting excess, percent yield. Oh, one more question. Sorry, I forgot. Is there one more? Is this it? All right. And it all almost fits. 2 givens, 2 answers. Take the smaller one. Is the actual yield 0.02? Well, that is a really sad actual yield. Because it's supposed to be 0.433. Therefore, they only got 4.6% of what they were supposed to get. What do you think your boss would do if you only did 4.6% of your job? Like, I worked 40 hours. I only actually worked about 32 minutes, though. Blame it on someone else? I think in most worlds that's a fired, right? You made one pizza. You were supposed to make 705. Let me arrange your hours so that you understand how many you're getting. You're getting 0 hours next week. So, and that's actually how they just do it in the hourly job, right? If they reduce your hours down to like 5, there's 2 things go. Wait, why am I recording this story? Well, at this point, some of you may have noticed that this should not be oxygen here. It should be iron. That is what we call a typo. It was the right mass, because you were given 0.33 grams of iron. I just wrote O2. Does that matter? Heck yes, it matters, because this is grams of iron, then this needs to be the mass of iron from the periodic table, which I did that part right? And then I changed it to moles. Then I used the mole ratio to rust. That's the formula for rust, Fe2O3. And then that's the molar mass for rust. Mass of oxygen. Oxygen's O2. So you got to do the mass of O2. Convert. Smaller answer. What's the name of the smaller answer? Theoretical yield. Occasionally, I know I'm talking about the test and it's still like a couple class days away, but occasionally people don't know the terms, and therefore the question is like, please tell me the value of the and you're like, I don't know what that term was. Right? It just is gobbledygook. So you have to actually know the terms so that you know what the question is so that you can answer it. If I said which answer would actually occur, or which answer is more likely to occur, you kind of go, it's the smaller one, the 0.433. But it's called the theoretical yield. Which one of these is the limiting reactant? Oxygen. Oxygen limits the amount of rust we can make. Iron is not limiting it, right? This is, in my opinion, a very fake question, because very rarely do you run out of oxygen unless you're passing out. That's probably not close to reality. I know when my car, I had a car in high school, was dinged up, scratched, and then the iron starts to rust. It wasn't running out of oxygen. There was plenty of oxygen in the air. It was running out of iron. Welcome back. All right. That is the last question. Here's we draw a picture of your happy face. No, you're angry. Okay. All right. Good luck. Hey, guess what your homework is? Worksheet 2. You're brilliant. Worksheet 2.